The next solid design principle we want to talk about is the interface segregation principle, which helps provide design guidance for our interfaces. So what the interface segregation principle says is that clients should not be forced to depend on interfaces that they do not use. The reason this is important is that it's often tempting to just keep adding more and more methods to the interfaces that we have rather than create new interfaces. And like the single responsibility principle for classes, interface segregation is all about making sure that our interfaces are focused on a tight, specific set of functionality. Let's take a look at the interface segregation principle as it might apply to Mario. So let's imagine we have a client class here called Mario Game, which is our main game instance for Mario. And this is traditional Mario, where the enemies run around the screen on their own accord and players move around and jump on different enemies. Right? So we need the ability to move Mario around the screen. We want to be able to set an AI so that we can update how the enemies move about the screen, right? So we want them to sometimes be easy and sometimes be hard, for instance. We want to be able to set the input. So player 1 can be Mario and player 2 could be Luigi. We also may want to set the names of our characters so that Alice can be player 1 and Bob can be player 2. And finally, we need to be able to update those enemies as they're running around the screen because they don't get moved directly. So you can imagine an extension to the Mario game where we've gone and created something called Mario Race. And in Mario Race, you only have players competing against one another. There are no enemies at all. And in this case, you're only going to need to have your move, set input, and set name methods available to you. We can also imagine a second extension to the game where in some crazy future world we use Mario to train self-driving cars. So what we want to do is we want to have a simulator called Mario Sim, and that's only going to make use of our set AI and update methods. It doesn't care about inputs or the traditional moving that comes from users, right? We just want the enemies to be able to move amongst themselves. All right, so this is the situation as we have it now. We have the figure interface, which has 4 concrete subtypes: Mario, Luigi, enemy, and turtle. And we have the Mario game client, which uses the whole figure interface, right? Because this is the complete game. But unfortunately, we also have this Mario race client, which only uses some of the interface, right? It's only interested in the parts that can move Mario around the screen, set the input, and set names, because this is for players playing against one another. And we also have this Mario Sim client, which also uses a different subset of the interface because it's only interested in set AI and update. And unfortunately, both Mario Sim and Mario Race are being forced to depend upon parts of the figure interface that they don't need. So how can we use the interface segregation principle to improve this design? If you think about the figure interface and how it's being used by these different clients, what you realize is you really need some type of player component, If you think about the figure interface and how it's being used by Mario Race, Mario Game, and Mario Sim, what you realize is you really need to separate the playable parts of the interface for controlling players from those parts of the interface that can deal with the non-player characters or NPCs within this game. So what we've gone and done is we've split figure into 2 parts. There's the player interface that has move, set name, and set input, and there's the NPC interface, which has set AI and update. And then what we've gone and done is we've gone and changed the subtypes, the concrete subtypes, so they extend the part of the interface that they actually care about. So what does this mean for the concrete games themselves? Let's take a look at that now. Now that we've split the player interface, we need to go and reattach our clients. So here we can see that Mario Race only has to depend on the player interface, which has the move, set name, and set input methods, the 3 things they actually cared about. And they don't have to worry about these NPC methods anymore, set AI and update. At the same time, Mario Sim only has to depend on the NPC interface and has no interest at all in the player interface. But what does this actually mean for Mario Game? Well, if you think about it, Mario Game actually uses both of these interfaces, and that's entirely reasonable. So we can just draw that directly into this design. And in this way, we're able to extend our design so that Mario Game can use both interfaces.